afternoon. As John pointed out, I'm a principal engineer at Amazon working on S3. And one of the organizers of this conference asked me a couple weeks ago if I'd be willing to do a talk for this. And I do a lot of talks at Amazon, technical talks. You know, I've done several internal presentations about S3 and so on. I ran a talk series at Amazon. And one of the things I learned about a talk like this is that you want your audience to learn something from doing a talk. You know, if you can bring one point home, you've probably done okay. And so I asked the organizer, what do you want me to do? And we went back and forth a bunch, and he's like, well, we could do this, we could do this. And I said, and finally he said, what I'd really like you to do is tell these people or communicate the fact that we're enterprise ready, okay? Now remember, I'm an engineer at Amazon. I am not one of the business guys. So to me, enterprise ready probably means something different than it does to you. It means that we're going to be running on the Starship Enterprise, and maybe we'll get Mr. Spock making S3 service calls, or for those of you who are a little younger, we'll get Lieutenant Commander Data making these calls. This is clearly not what he meant by enterprise ready. And so, enterprise ready is kind of a difficult thing for me to answer, or as an engineer to answer. So what I'm going to do is take this in a completely different direction. And we're going to go with CompSci 101. And we'll kind of step through. So we're going to do the abridged version. We don't have a lot of time. And we'll do it without a final exam. So the first question you usually want to start with in computer science is, what is a computer? And a computer is composed essentially of three different subsystems, right? You have to have memory. And I love this tape drive. Lots of people have been knocking tape today, but it's memory for the machine. You have to have processing. You have to have a way of executing instructions on that memory and doing something. And you need an I/O subsystem. And you put those three things together, and that gets you a computer. And that's as true today as it was way back in the 1946. I think this is a picture from ENIAC way back in 1940s. So what's changed? What's changed about this? Well, today we have this thing called cloud computing. And cloud computing is also an interesting thing in that it's hard to define what cloud computing is. There's a couple hundred people in this room, and I'll bet you these 100 people all have a slightly different view of what cloud computing is. I found this picture on the internet. Somebody says cloud computing even has the kitchen sink in it. And to a certain extent, that's kind of where we're at. It's a somewhat ill-defined concept. And we were in this boat probably in the mid-90s. There was this idea of what is the World Wide Web? And at the time, email was part of it, or some people considered email to be part of it, or there's Gopher and all these things. And today, in the 2012, we all have a pretty clear concept of what the web is. But back in way back when, we didn't. And we're in that same spot right now with cloud computing, where the definition is somewhat ill-defined. So instead, it's easier to talk about distributed computing. And distributed computing is kind of like thinking about computers there's some things that you need, that core functionality that you have to make distributed computing. And the first one is obviously computers, right? You're going to do computing. You need a bunch of them. One isn't going to work so well for distributed computing. You need storage. You need some place to put your data. And you need a network to move the data among the computers and the storage. And if you put these three things together in the right way, you end up with distributed computing. And what I'd like to do today is get you guys to think about your problem of whatever it may be that you're trying to do in the context of distributed computing. We're here at the storage event, so the main thing that we've been talking about all day is storage. And I want to go through these four storage offerings of AWS. But in the whole time we're doing this, I want to kind of keep the context of this distributed computing and how these three components fit together. So we've been doing a lot of talking about S3, but I want to take a slightly different, more fundamental approach. So what is S3? And essentially, S3 is nothing more than a key value store. The keys are the names of the objects that you store. They could be like my JPEG or my picture.jpg. They could be a movie. They could be a Word document. And the value is just a sequence of bytes. And we have this very simple API when we called it the Simple Storage Service, because when we started out, this was essentially the API that we had. We had 4 methods on. You can put an object, you can get an object, you can list the things that you have, and if you can put, you should probably be able to delete. And this was the Amazon, or the S3 API when we started out. We saw a copy of this graph earlier today. S3 continues to grow. We're up to 905, or at the end of Q1, we were at 905 billion objects, and we have more now. Some of the features of S3. So S3 will let you store essentially anything, any sequence of bytes. You can store an object as small as 1 byte, or something as large as 5 terabytes in S3. Just to put 5 terabytes is a lot of data. To put that in context, if you have a DVD movie, a DVD is about 6 gigabytes. 5 terabytes is equivalent to about 830 of those DVDs. So 5 terabytes is a really large single object for us, for almost any use case. We've talked a bunch about the 11 nines of durability. We'll talk a little bit about how we get to that availability, or that durability. And we have, we're 99.99% available. And what does that mean? Well, there's a certain number of minutes of outage where you may not be able to retrieve your object. Now, availability is really important for us too, and it's important for Amazon because we actually will give service credits if we go below 99.9 availability. And there's information on the website about what those service credits are. But we are very motivated to keep our availability up. Another key feature that we haven't talked so much about today is low latency. The typical median time to fetch an object from S3 is 50 milliseconds. Now, if you have a 5 terabyte object, obviously we can't get you that object in 50 milliseconds, but what we can do is we can start streaming that object to you within 50 milliseconds. So that's actually pretty fast, especially given the 905 billion objects that we have to sort through. It's inexpensive. We talked about the cost of S3 today. It starts out at 12.5 cents a gigabyte a month, and again, pay as you go. Topic's been fairly well covered, and it's secure. And we've talked some about the security, and I don't think we should go into that too much anymore right now. We can. So I wanted to talk a little bit about durability for S3 and how durability works. So what happens when you put an object in S3 is, as that object arrives, we start sending the bytes to a data center, and we store it in multiple data centers. And before we actually acknowledge to the user that says, hey, we've stored your object, we've actually stored it in multiple data centers. So, if the asteroid hits and takes out one of our data centers, we are sure that we have that data in other data centers and can maintain that durability at that extremely high level. We talked a little bit about reduced redundancy. It's a less durable offering. So it's 99.99% available. We still do the replication into the other data centers, but we make other trade-offs that we don't for our standard offering. So we may make less copies in the data centers, or we may repair those objects or bias against repairing these objects when, say, a disk fails. So these reliability trade-offs that we've made to make this offering. And for that, we pay, because of that trade-off, we charge less for it. And right now, if you store a gigabyte for a month, it's 9.3 cents a month. And if you store over 5,000 terabytes, we will charge you 3.7 cents a gig a month. So I wanted to talk a little bit about some of the use cases, and a lot of people here today have talked about many of these. And this is kind of from my viewpoint and the engineering side that we think about this. So there's backup and archive, content storing and sharing, website hosting, and the big data processing. So let's talk about backup first. One of the big advantages of using S3 for backup, and as we've touched on already, is that it's off-site. You know, as soon as your backup is complete, we've got this data reliably, durably stored in the cloud. Another key point is that it's highly available. Unlike traditional tape backup that you may off-site, if you ever do actually need to restore this data, you don't have to wait for a truck to deliver some tape from a cave before you can do your backup, or before you can do your restores. So, you know, the fact that we can get your data in 50 milliseconds, I think, is hugely valuable in the restore case. We were talking a little bit earlier about the API for S3, and that it had essentially these four methods. Since we've launched this product, we've added lots of different features to it, to S3, and one of them is lifecycle management. And one of the key reasons why we added lifecycle management is to help manage backups. And what lifecycle management is a way that you can set policies on your objects and your buckets to say, go delete these objects after a certain amount of time. And so lifecycle management helps with the backup use case. The other common use case in this vein is archiving. And we've added some features to S3 to support archiving. One of them is versioning. And what versioning is a feature of S3 where we will never overwrite your object. So if you have some important content, maybe you have the original copy of a movie, and somebody transcodes it, and they say, oh, I'm going to store this transcoded object up into S3. Well, on a typical file system, that would overwrite the existing copy, and you would potentially lose that original master. What versioning does is that we can turn this on, and yes, we will take your new copy, your new write, but the old one will also exist, and we will never overwrite the data. We talked a little bit earlier today about MFA tokens, or the multi-factor authentication. So you can get one of these physical Jamulta keys and enable multi-factor authentication on your bucket. So now, even if your employees or whomever cannot go delete this data unless they physically have that token. So to also support the use case for archive. And then again, we're talking about, I wanted to bring this back to the distributed computing part of it. And that is, there's a service we call import-export. And this is the networking aspect of archiving, and is a great way to get the data into into S3 for large data sets for archiving. Another common use case is delivery to third parties, content storage and sharing, and content distribution. And so this content storage and sharing, I don't imagine many of you in this room are actually going to go off and implement that. That's why we have these partners in the room today. They're building systems that make that happen. But what we do is we provide the technology that enables that storage to happen and the sharing. You could build this on top of S3 yourself, and we've got certain policies or access control lists and security features that can allow you to build the sharing. But traditionally, you know, it's those features that enable our partners to build those systems. And then there's content distribution, which is a really good use case for S3. For, say, software updates where you have a huge amount of, or a large object or distribution that you want to get to your customer. Or maybe it's a movie, right? Some instructional video that you want to make available. S3 is a great way to put that up make it available on S3 and hand that out to your customers. Oh, the red button. Push the green button. Website hosting. So website hosting is another common use case, and I think one of our partners today is going to be talking about their use case for website hosting. It's really good for setting up static website content. It's very easy to set up. We have many users right now who have small and even large-scale websites who have use S3 as the storage for their website. It also integrates well with CloudFront to do distribution. which goes back to our networking side of the story. And the other thing that's really powerful about using S3 for this is that it scales. S3 actually has huge pipes to the internet. And so if you have lots and lots of traffic, S3 is a great way to be hosting that content. So again, let's go back to our distributed computing story. So far we've been talking about storage quite a bit. And the other part, we've touched on the networking, whether it's AWS import-export, but there's also your network involved in thinking about this. And so as you consider how to move your data into the cloud and leverage this distributed computing, you have to think about your network. Janesh talked about using your network today. But the other part of this is that we really don't talk about so much is the AWS network. And because where that kicks in is things like our replication and the things that we have to do to manage durability that aren't part of what you have to consider. So we've talked about the two legs of the distributed computing. There's the other piece that we need to talk about is compute, to kind of get those three pieces of distributed computing. And for compute, what AWS offers is elastic cloud compute. Now, we haven't been spending a lot of time talking about EC2 today, so EC2 is rent computers from Amazon. We have many instance types. We have some with lots and lots of memory, some with lots of processor, some that are actually very, very small for that fit certain use cases for our customers. We have this offering called auto scaling that lets you add or take away compute capacity as you need, and an offering called reserved instances where you can essentially guarantee that you have compute capacity. So we have a compute offering, and now that we have these three things, we have the network, we have compute, and we have storage, there's some other use cases that pop up. One of them is data processing, or the current buzzword for the year is big data. And Janesh, I think, is going to be giving us another talk about some of the big data properties or possibilities that you can do with Amazon Web Services. But I'm going to touch on a couple of them. One of the common ones is log analysis. And the reason that I know this is a common big data problem is that we use it a lot in S3 itself. If you can imagine, if we're doing 650,000 TPS, and we want to go find out something about request load over the last day, this is truly a big data problem. And we will use these services to go analyze our logs. And like I said, Janesh will be talking, and there'll be more to come in a little bit. If you have computing, we have these EC2 instances. There's S3, as I said, is an object store. And object stores don't work very well with operating systems. They need something to read and write data from. And so for EC2, we have two different kinds of storage offerings. One is the local instance, and that is actually a disk physically attached to that machine, and it may be shared in a multi-tenant disk that is transient. It's ephemeral. If the machine crashes or you shut your instance off, that data is lost. But it's really good for doing things like local logging and so we've had the EC2 or the instance offer. Later on, I think in 2008, we added the elastic block store. And what the elastic block store is essentially it's attached storage. I should go. So it's attached storage for these EC2 instances. And some of the features of EBS are you can make volumes from 1 gig to 1 terabyte in size, and these EBS volumes are replicated. So we have a master and a slave. Unlike S3 replication, where it's much more complicated, this is a very simple replication strategy, and we keep it inside a single availability zone. So, and the reason that we do that is for latency purposes. The availability zones are fairly far apart. Disks typically want access times in the 8 to 10 millisecond range. So the data center, or the master and the slave, have to be relatively close together. And we keep these in the same availability zone as your EC2 instances run. So to keep those latencies down. The other key point of EBS is that it's persistent storage. When you write your data to an EBS volume, you can shut that instance down, bring it back up, and the data will survive that shutdown and startup. So if your software crashes on the machine and it crashes the OS, it will continue to persist. And it is, like I said, attached storage. A couple of other features of EBS, like I said, it's a replicated block store. And another thing that EBS does for us is it allows us to, or allows you to take snapshots of your data. So these are point-in-time snapshots of the volumes. And those snapshots are then moved into S3, where S3 is, and they're stored in standard storage, and so they have the same 11 nines of durability. And again, they persist after shutdown. So what are some of the common use cases for EBS? Well, the first one is a file system. Once you've attached this storage to your EC2 instance, a traditional or common use case is to make a file system on that. Because the attached storage essentially looks like a disk drive to the EC2 instance. You can format it, build a file system, and use it as a traditional file system. Another common use case is to make boot volumes. And what a boot volume is essentially the disk where the machine will boot from. And on the boot volumes, you put your key software that you need it to run, whatever has to happen when that machine comes up. Then you can take snapshots of that boot volume and replicate that across many machines. So if you need 100 servers running a particular piece of software, you'd make or use boot volumes to do that. Another common use case is database block storage, and this is what RDS actually uses inside of in the cloud. Is it takes these EC2 instances, mounts it with block EBS volumes to make lots of volumes on the EC2 instance to run the RDS offering. That is alphabet soup. Okay. RDS, Relational Data Services. And then the last one that's kind of interesting, and I think it's interesting, probably not so applicable to what we're talking about here, is we have this thing called public data sets. And what public data sets are snapshots that are available in EBS for public data. There's one available with genetic sequencing data. There's another one with a bunch of census data, which might be interesting for some of you to actually mount up and compare to to do analytics on. Okay, the next thing that I wanted to talk about was the AWS Storage Gateway. Here's kind of a high-level architecture picture of the gateway. It is a virtual appliance that runs in the customer's data center. It actually uses attached storage inside your data center. And what it does is it presents an iSCSI interface to your applications. And as you write data to it, or it stores that data very, very temporarily and moves it up into a service inside of our cloud, the AWS Storage Gateway service, which then writes that data into S3. The data that it writes actually is written in the exact same format as a EBS snapshot. So what this lets you do is use storage in your data center, move it up into the cloud, and then you can mount that data onto an EC2 instance. And the other thing that you can do is in reverse. You can do compute in the cloud, build a volume, take a snapshot of it, and make that volume available in your data center via the gateway. So some of the uses for this are, first of all, disaster recovery. I mean, that ability to move a snapshot from the premise into the cloud and be able to access it from inside the cloud really is a compelling disaster recovery use case. Backup, offsite backup, you can write to the iSCSI device as essentially like a tape drive, and make offsite or immediate offsite backups. And then, as I pointed out, you can use these snapshots in EC2. So the last thing that I want to kind of talk about is the networking offering. Because, like I said, distributed computing is made up of three parts. There's the network, there's the compute, and there's the storage. And we have a bunch of things that we've talked about today about the network. And the classic for S3 has always been HTTP and HTTPS. That was like the first and only way to get data into S3 when we first launched. Now we've added, as time has gone by, we've added more offerings to the virtual private cloud. The ability to extend your network into the cloud is kind of what the VPC offering is for. Direct Connect, which is another networking offering that lets you meet up with our network at certain locations. You can go look at the website and find out where those key locations are. And then AWS Import-Export, which is a service where you can take disks and ship them to us, and we will import those into either S3 or EBS. We recently added the ability to import directly into EBS. And the other thing that's cool is you can also export your data. So if you have key data that you have in the cloud and you want to get it out, you can use export so that you can get that data out in bulk relatively quickly. So we've been talking about these distributed computing things, and I think the key part of this is that just like in the olden days when you would buy a computer and you'd have to think about how much memory or how much processor do I need, today we've gone one step up from that, and now it's like, how much compute do I need? How much compute do I need to solve my big data problem? How much storage do you need? And one of the cool things about what we're doing is you get to use what you need. You don't have to buy this up front. And I put up here that the network has kind of become Amazon's responsibility. And that's true if you're staying inside the cloud. If you're doing the big data processing inside the cloud, we take care of that networking. We have to get the data from the storage to the compute and back again. And so we've kind of covered those three pillars. So just kind of a recap, we talked a little bit about S3 and how it's put together. EBS, the EC2 offering. The storage gateway, a way to get data from your data center into the cloud, and then import-export for moving data to and from our services. So just to wrap up, are we enterprise ready? Well, what I'm going to do is not answer that question, but leave you with some of our customers who are already utilizing us. With that, thanks.